At 14:23 local time, a single Ukrainian Su-27 skims a river valley so low that the wings are almost level with the treetops, aimed straight toward a Russian-controlled dam whose concrete spine is feeding the front with supplies and reinforcements. The plan is brutally simple: break the spillway joint and force logistics to detour. The execution is not. At this height, every bend in the river is a blind corner, every ridge a wall, and every second a bet that the next warning tone will not be the last sound the pilot hears. The jet has been steady for minutes, engines breathing cool, dense air, when the radar warning receiver snaps from quiet to a harsh, continuous scream that means one thing: a missile is already in the air. The pilot has only a handful of heartbeats before detonation geometry closes, so he throws the aircraft into the tightest part of the valley and pulls hard, forcing the airframe into a crushing turn while the river flashes beneath like a guiding line painted in steel-gray water. 317 descends on a ballistic arc, spending most of its flight trusting inertial math and a predicted intercept point rather than what it can truly see. A ground radar tries to refine that prediction by sending course corrections again and again, but those updates are only as good as the track that produces them. The lower the jet hides behind terrain while pulling high G, the uglier that track becomes, and the more the corrections degrade into educated guesses. Down at river level, the Su-27 weaponizes the landscape. He dives until spray kicks off the surface, using terrain masking so aggressively that the jet's silhouette vanishes and reappears in fragments. The warning display flickers with a second launch, then a third. As the book crew commits to the valley exit, they believe the jet must cross. Their solution is logical on paper: saturate the choke point. The problem is that logic assumes the target behaves like a line on a chart, instead of a pilot with options. The first missile reaches the moment when it should finally become a hunter, switching from guided prediction to its own seeker. The pilot times everything around that switch. He rolls, shifts the nose, and slips into a tributary valley that branches away from the expected path, turning the should-be into empty air. The seeker cone sweeps terrain returns and finds no clean target, and the missile defaults to detonation logic, bursting behind the jet with a flash that is loud but useless. The second and third missiles repeat the same tragedy, arriving where the aircraft would have been if it had flown like a diagram. Each time, the pilot forces a recalculation by chaining maneuvers that keep the jet energetic even at low altitude. A split movement that drops altitude fast, then a reversal that climbs just enough to change intercept angles, then another roll that hides the fuselage behind rock and ridge. The missiles detonate without effect, and the valley keeps swallowing the Su-27 whole. For the book battery, the exchange is becoming a nightmare of spent shots and fading confidence. A full launcher has been emptied, yet the target is still alive, still moving, and now farther away than the firing solution expected. The Su-27 accelerates out of the worst of the funnel, but the mission cannot relax. The dam is still ahead, and the jet cannot climb freely without exposing itself. The pilot knows the next engagement will not be the same mistake repeated. It comes from a second launcher positioned south with a better angle, a geometry that reduces the terrain's protection for a few seconds as the jet crosses a gap between ridgelines. The fire control radar locks, track quality surges, and the shot is no longer a guess. But the Su-27 is not blind. Its L-150 pastel radar warning system does more than shout. It analyzes pulse rhythm, scan pattern, and strength, and from that builds a rough map of where the threat lives. The pilot measures his escape against hard limitations: wing loading that resists tight turns at combat speed, and low altitude that punishes hesitation. He chooses the one move the airframe can deliver instantly: vertical aggression. As two more missiles launch, he drives throttles forward and pulls into a steep nose-high climb that turns the jet into a rocket, trading terrain cover for altitude and forcing the intercept math to chase a target that is no longer staying in the valley's rules. The climb shoves the Su-27 above the engagement comfort that the book expects for a low-level runner. The missiles attempt to lead, but their algorithms assume normal behavior, not a sudden zoom that changes vertical separation faster than control surfaces can match in the terminal phase. The proximity fuses sense the aircraft, but compute the missed distance as too wide for a decisive fragment pattern, and both weapons detonate below the jet, loud punctuation marks that fail to end the sentence. That success carries a cost. The moment the jet climbs, it becomes visible to every radar that can reach the sky. The pilot pushes over and dives back toward the deck, trying to return to the river's cover and the dam's approach line, when a new presence appears on the threat picture, an A-50U mainstay, orbiting far to the southeast, high and patient, watching the region for patterns rather than perfect tracks. The Su-27 is not a clean blip, only ghosts that appear and vanish. The mainstay's crew turns those ghosts into a story by noticing timing and direction, disturbances that recur, move east, and align with the river network. Correlation climbs until probability becomes action, and a data link queue snaps toward a nearby Su-35 on combat air patrol. On the fighter's display, the intercept box appears with bearing, speed estimate, and altitude band, collapsing a wide search into a narrow slice of terrain. The hunter now knows where to look, and the valley is running out of secrets. The Su-35 pilot wastes no time converting the queue into motion, turning hard and feeding power until the engines settle into a steady, hungry push that brings the aircraft onto the intercept vector. Without the airborne warning aircraft, this would be a blind search through valleys and clutter. But with it, the geometry tightens into something lethal. The fighter's radar focuses its full output into a narrow slice of airspace, not hunting broadly, but interrogating exactly where the target must be if the math is right, collapsing uncertainty into opportunity. Under the wings, two R-77 missiles wait, selected for a beyond visual range shot that favors this geometry almost perfectly. The parameters line up with uncomfortable clarity. The target is low, fast, and angled just enough off the nose to stay within seeker limits once active. The Su-35 pilot checks range and aspect and understands the difference between this threat and the ground-launched ones already defeated. These missiles will not depend on continuous guidance once released. They will hunt on their own. The Ukrainian pilot sees the change immediately as his warning receiver updates, not with a static scream, but with a new signature that carries its own meaning. He knows the clock this time is longer, measured in dozens of seconds rather than heartbeats. But the danger is deeper. An R-77, flying most of its path on inertial navigation, does not care about brief terrain shadows the way surface-launched weapons do. When it goes active, it will search aggressively across a wide cone. He accelerates instead of turning, pushing the jet to the edge of what low altitude will allow, skimming the river at 30 meters and letting speed become his first layer of defense. The aircraft trembles on the boundary between control and disaster, where a sudden pull could mean a high-speed stall, or worse. This is deliberate. Every option he keeps open depends on arriving at the critical moment with maximum energy and minimum exposure. The first R-77 leaves the Su-35 and dives toward the valley at high supersonic speed, its flight path smooth and confident. For much of the run, it is blind, trusting numbers rather than sight, counting down distance and time while the Ukrainian pilot waits. He does not react early. He watches the terrain ahead and chooses a ridgeline not as cover now, but as cover later, when the missile seeker will finally demand a real target to lock onto. The moment arrives with brutal precision. As the missile transitions to autonomous search, the Su-27 disappears behind a 500-meter ridge, vanishing at exactly the wrong instant for the weapon. While the R-77 pulls up to clear the ridge, the Su-27 reverses direction through a hard maneuver that would shred energy in lesser fighters but holds here through thrust and control law discipline. By the time the missile crests and sweeps its wide field of view, the target is gone, already accelerating down a perpendicular valley that rewrites the intercept geometry faster than the seeker can adapt. With fuel nearly spent and no lock achieved, the missile defaults to its backup solution, detonating where the aircraft should have been if it had continued straight. The blast scatters thousands of fragments through empty air, a lethal cloud with nothing inside it. The Ukrainian pilot feels the concussion through the airframe but sees no damage, only confirmation that timing and terrain have once again beaten prediction and probability. The Su-35 pilot does not hesitate. Doctrine is doctrine, and the second missile comes off the rail even as the range stretches and the solution degrades. This shot is worse from the start. The target is farther, weaving, and repeatedly masked by terrain that fractures radar returns into pieces that refuse to settle. Still, the missile flies its path, transitions to search, and encounters the same problem. A seeker cone filled with ground, not sky. The second detonation is even farther from the Su-27, a distant flash that marks the end of the aerial chase. The Russian fighter considers pursuit, but fuel calculations are unforgiving. After 90 minutes airborne, there is not enough margin to chase a low-level runner through valleys far from base. The Su-35 turns away, leaving the Ukrainian jet alone again with the river, the dam ahead, and the part of the mission that has been quietly unfolding all along. Throughout every evasive move, the pilot has been preparing the weapon that justifies the risk. Beneath the wing sits a GBU-38 JDAM extended range, powered up and listening, its internal receivers searching for satellites and aligning itself with coordinates loaded long before takeoff. In seconds, it knows where it is to within meters and where it must go to break the spillway joint that holds back more than water. Altitude is now the currency that matters. The bomb's folding wings promise distance, but only if released high enough to glide. As the Su-27 climbs toward that window, new interference creeps into the system, subtle at first, then unmistakable. Satellite signals weaken, jump, and lie. The dam is defended not just by missiles, but by electronic teeth that are about to test whether this attack can still reach its mark. As the Su-27 climbs, the bomb's status symbology begins to flicker, not from damage but from confusion. Signal strength from one satellite collapses, then another, dropping from clean certainty into noise that no civilian receiver can reconcile. This is the Zettel R330Z at work, a dedicated electronic warfare system protecting the dam by transmitting false satellite timing that looks authentic enough to deceive anything not prepared. The bomb's commercial navigation solution begins drifting hundreds of meters in seconds. Inside the cockpit, the pilot watches two truths diverge. One display insists the aircraft is sliding north of its actual track, while another, fed by a hardened military receiver, remains calm and consistent. Ukrainian engineers anticipated spoofing and integrated selective availability anti-spoofing modules that authenticate encrypted signals civilian systems cannot reproduce. The bomb is confused, but the jet is not. The question becomes whether the weapon will accept the truth in time. The climb continues, measured and intentional, threading a narrow vertical profile the pilot memorized long before this flight. The jammer intensifies, focusing its antennas and increasing power output as it senses the approaching threat. What it cannot do is change its own physics. The antenna pattern that blankets low altitudes leaves a thin null zone above 3,000 meters. As the altimeter ticks upward, the aircraft passes through that invisible seam. For a brief window, the noise collapses. The military receiver snaps to 8 authenticated satellites with accuracy restored to meters. The pilot does not hesitate. He inputs the final authorization code, a last gate designed to prevent manipulation, and watches the bomb's logic accept a late correction that overwrites the lies it had been fed moments earlier. The status shifts to ready, and the dam fills the forward view. He presses the release. The JDAM extended range separates cleanly, falling free before spring-loaded mechanisms transform it from a blunt cylinder into a glider. Wings rotate outward and lock, tail fins snap into place, and within half a second the weapon is flying its own mission. Almost immediately, the jammer reasserts itself, drowning the bomb's receiver in crafted interference. GPS goes dark again, but the damage is already done. Inside the bomb, a quieter argument takes over. The inertial measurement unit, built around ring laser gyroscopes and precision accelerometers, asserts continuity. It knows where it was at release and how it has moved since, integrating every rotation and acceleration with cold confidence. Over a 4-minute glide, drift will accumulate and wind will push, but the math remains bounded. Perfect information is gone. Good enough remains. The bomb glides through descending altitude bands, correcting its attitude every fraction of a second to stay aligned with a trajectory calculated against the dam's vulnerable geometry. Without GPS, it cannot sense wind directly, and a steady push nudges it northeast, adding meters of error that stack with inertial drift. Ukrainian planners accounted for this long ago, choosing not a pinpoint, but a zone where any hit would compromise the structure through physics rather than precision. At 200 meters above ground level, the weapon commits. Control surfaces drive the nose down, steepening the dive until the impact angle approaches vertical. Speed climbs rapidly, converting altitude into kinetic certainty. The radar altimeter counts down in sharp steps, indifferent to jamming and weather alike. 100 meters, 50, 20. The dam's spillway joint fills the guidance solution not as a picture, but as a destination. Far above, the A-50U continues to orbit, but its role has shifted from hunter to witness. The radar picture no longer shows a consistent track, only fragments that dissolve into clutter. Analysts will later reconstruct the sequence frame by frame, noting where assumptions broke and where geometry favored audacity over caution. For now, the aircraft remains a distant observer, unable to offer a clean handoff to fighters without exposing them to the same terrain traps that swallowed earlier solutions. On the ground near the dam, electronic warfare crews monitor their displays and see their jamming return to baseline effectiveness, unaware that the decisive moment passed during a brief altitude window they could not close. Their system worked as designed, blinding civilian receivers and corrupting timing data. But design has limits. A null is still a null, and seconds are still seconds. The realization will come later, after reports and imagery align. The pilot levels out and checks fuel, systems, and engine response, confirming that the aircraft is still whole despite the violence it threaded through. He does not replay the missile misses or the detonation behind him. Those details belong to analysis rooms, not cockpits. What matters now is separation, distance, and the discipline to avoid shortcuts that invite one last engagement. Survival, like the attack, is a process, not a moment. Behind him, water continues to force itself through the damaged spillway, turning structural compromise into operational disruption. The dam was not annihilated, but it does not need to be. Even partial failure reshapes downstream logistics, forcing engineers and commanders to adapt under pressure. The effect will propagate through schedules, routes, and assumptions. Exactly the kind of second-order consequence that makes a single sortie worth the risk. As the jet follows the river away from the area, the terrain that once threatened to kill it now becomes a shield again. Ridges block line of sight, valleys scatter radar energy, and the aircraft dissolves into the background it exploited from the beginning. The same physics that betrayed missiles now protects the survivor, indifferent to flags or intent, responding only to angle, distance, and mass. The mission's design reveals itself in retrospect as a chain with no redundant links wasted. Low-level ingress forced air defenses to commit early. High-G maneuvering degraded track quality. A vertical escape exploited missile envelopes. Electronic countermeasures were anticipated and bracketed. Weapon release was timed to a vulnerability measured in seconds. None of it relied on chance. Each step reduced the problem to something the next step could solve. For the Russian defenders, the engagement becomes a lesson written in missed intercepts and partial truths. Missiles functioned, radars detected, fighters launched, jammers broadcast. Yet the outcome still bent against them because each system assumed the target would behave within expected bounds. When those bounds were violated, the margin collapsed faster than adaptation could catch up. For the Ukrainian pilot, there is no celebration in the air, only focus. He keeps the aircraft inside terrain until friendly coverage and distance finally widen his options. Only then does altitude return as a convenience rather than a liability. The dam recedes into memory, replaced by checklists and navigation, the quiet routines that follow moments of compressed intensity. Long after the jet lands, analysts will trace the engagement backward, aligning timelines and telemetry to understand why it worked. They will measure seeker activation points, jammer power curves, climb rates, and drift errors, turning lived seconds into charts and probabilities. The story will look inevitable on paper, even though it never felt that way in the cockpit. What remains undeniable is that a single aircraft, flown with discipline and intent, forced multiple layers of defense to expend resources, reveal positions, and fail in sequence. The damage to the dam is visible, but the deeper impact lies in confidence eroded and assumptions rewritten. That is the quiet arithmetic of modern air warfare, where success is counted not just in explosions but in the options denied afterward. The Su-27 disappears from the operational picture the same way it entered it, low and unremarkable, leaving behind only disturbed water, spent interceptors, and a structure that no longer holds as it once did. The mission ends not with noise, but with absence, as the aircraft slips back into the airspace that can no longer say with certainty where it is or when it will matter again. At 2:30 a.m. on October 25, 2025, 3 guided rockets skim roughly 8 feet above the Belgrade River, threading toward the dam's control gates with a cruelly simple rule. There is no second attempt. Miss the gates by a few feet, and the Russian fortress behind the dam remains a $100 million problem, untouched and fully awake. Hit the wrong concrete, clip the main dam wall instead of the valve housing, and the strike becomes a self-inflicted catastrophe that sends a flood toward Vovchansk with the kind of speed that makes maps feel dishonest. The clock is already counting down. 47 seconds from launch to impact, a short flight that will decide whether this is a surgical trap or an irreversible mistake. That 47-second arc is only the visible finale of a 90-minute knife fight against physics and Russian detection, starting in a muddy field about 50 miles from the border, where an M142 HIMARS truck creeps into a pre-calculated firing position under darkness. The launcher does not feel like artillery here, it feels like contraband. Russian forces have become efficient at hunting the platform, and Ukraine has already lost 4 of these launchers in 2025 to a combination of Iskander missiles and Lancet drones, a pattern that teaches crews to treat every ignition as a flare. The heat signature of a HIMARS launch is described like a dinner bell, and the crew acts like everyone is already listening. The strike is framed as something stranger than destruction, the opening move in what the narration calls a dynamic double flood trap. Not to vaporize a bunker, but to turn the defended command post into an island and force its occupants to react to water instead of aircraft. That concept depends on timing and human behavior more than explosive yield, because the defenders are trained to look up, not down. Their routines are built around radar plots, missile warnings, and the expectation that the next threat comes from the sky or the tree line. The trap assumes that if the ground begins to drown them quietly, panic will shove them toward higher ground. And higher ground in this layout happens to be where air defense vehicles and checkpoint positions sit. At around 2:30 a.m. plus 15 seconds, the first reaction on the ground is not clever, it is loud. Around 80 Russian infantrymen and 3 BMP-3 vehicles in thick fog and heavy humidity hear a low roar and interpret it as an attack they can shoot back at. Floodlights snap on and dissolve into vapor, turning visibility into a rumor, while tracer fire from AK-47 rifles throws red lines into air that will not reveal targets. A soldier shoulders an RPG-7 and fires into the dark river, getting a splash and nothing else. because the problem is not their weapon, but their eyes. The script leans on the fog and soaked oak and birch leaves on the riverbank, a wet blanket that compresses visibility to less than 100 feet and turns disciplined defense into startled noise. Above that confusion, the rockets are described as indifferent machines, crossing the last stretch at a speed the narration frames in the hundreds of miles per hour, while the ground fires at ghosts. At 2:30 a.m. plus 47 seconds, the impacts arrive not as one theatrical fireball, but as 3 sharp cracks, 600 pounds of PBXN 110 detonating with the intent of a surgeon rather than the mood of a bomb. 2 rockets strike the sluice gate control building, tearing concrete and steel supports, while the third fractures the valve housing and creates a leak, described as about 3 feet. The immediate effect is almost quiet, a cold slick of river water seeping and then rising with an unnatural urgency, deepening fast enough to feel like the terrain has been reprogrammed. Within roughly a minute, the water is described as around 1.6 feet deep, and the defensive geometry collapses because the positions built low for protection become traps that fill from the floor up. Ammunition soaks, radios short out, boots disappear under rising water, and panic upgrades into terror when soldiers realize the river is now inside their holes. They abandon the dugouts and scramble for higher ground where the air defense vehicles are parked, and in doing so, they perform the key motion the planners gambled on. They run toward the next layer of defense and reveal it. Checkpoint gun positions and previously hidden Panzer systems are no longer hidden, not because a drone spotted them first, but because frightened men moved like a flare path, pointing at their own shelter. Back at the launch site, the script pivots to the detail that makes counter-battery feel inevitable. The 3 empty rocket pods are glowing at roughly 1,800 degrees Fahrenheit, a billboard in infrared. Standard procedure calls for cooling time, but the crew treats standards as an invitation to die. The heavy truck, described as around 35,000 pounds, lurches through mud toward a pre-planned hide site about 5 miles away beneath dense tree canopy, a short relocation that is less escape than sprint. Moments after the launcher disappears under trees, an Iskander-M ballistic missile impacts the firing position and turns the field into a crater, a perfect strike on a target that has already moved. With the dam hit and the launcher gone, the rising water becomes the first weapon in the second phase, aimed initially at electronics rather than bodies. About 10 miles away, a Krasuka 4 electronic warfare system surges to life to jam command and control links. And the effect on Ukrainian first-person view operators is described as instant blindness. Screens dissolve into static, connections sever, and roughly 25 FPV drones, each carrying a 4.4-pound shaped charge, suddenly have no human hands on them inside a jamming zone described as 186 miles. The script then snaps into its twist. The drones do not fall. They wake up, switching from remote control to autonomous mode, navigating with optical flow sensors and 360-degree LiDAR, ignoring GPS and instead reading terrain cues and following the newly formed river channel created by the strike, as if the flood itself is now a corridor through the electronic wall. The Russian response does not end with jamming, because electronic denial buys seconds, not safety, and seconds matter. As the autonomous drones ride the river's new shape, the defenders activate what the script frames as their most powerful eye. A Nebo-M long-range radar spins up, its massive antenna completing a full sweep in roughly 6 seconds and slicing through fog that blinded human eyes. On the scope, 2 stories appear at once. 3 high-speed signatures streaking away from the engagement zone, identified as the departing rockets, and a second cluster that makes no immediate sense. A loose cloud of 10 slow-moving radar contacts hovering around 50 feet above the ground. For the operators of the Buk M1 air defense system linked to the radar, this looks like a textbook problem with a clear answer. The fire control computer flags the 10 contacts as the priority threat, the kind that lingers and grows, and the order to engage comes without drama. Two 9M38 missiles launch into the night, accelerating to several times the speed of sound, their guidance optimized for targets that advertise themselves. Seconds later, they detonate inside the cloud. Proximity fuses spraying fragmentation, and 2 of the 10 contacts vanish from the screen. It is a clean kill by doctrine and a catastrophic misread of intent. Those 10 contacts are revealed as decoys, sacrificial FPV darts programmed to look threatening by flying higher and slower, bait designed to draw fire from the most expensive layer of Russian air defense. While the book crews confirm their success, the real swarm is moving unseen. 15 FPV darts skim roughly 6 feet above the water, masked by radar clutter from wet leaves and rising floodwater, exactly the kind of interference the Nebo-M's algorithms are trained to filter out. In doing their job, those filters erase the Ukrainian attack force entirely, and the decoys achieve their real purpose by exposing the precise location of the long-range defense. As the flood continues to spread, another consequence appears that has nothing to do with missiles. Water seeps over the main railway line, connecting the Belgrade depot to the front, turning a critical supply artery into an impassable swamp. Rails that move ammunition and fuel become submerged markers of isolation, and the concept of the fortress as an island stops being metaphor. Logistics are not destroyed by fire here. They are drowned by inches. The defenders are now cut off in layers, with water disrupting ground movement even as the sky fills with signals and counter-signals that no longer matter as much as elevation. At around 2:33 a.m., the final defensive ring engages. 2 Panzer S 1-point defense systems come fully alert, built to swat threats that slip through everything else. The fire control system locks onto a lead drone, and a 5-7 E6E missile launches, accelerating to roughly 2,300 miles per hour. The drone's onboard logic reacts faster than human reflex, executing a violent evasive maneuver while broadcasting the missile's trajectory to the rest of the swarm. Instead of scattering, the remaining drones recalculate together, using the missile's path as a temporary safe corridor to surge forward. The missile detonates over empty water, fooled by abrupt dives and ground clutter, and for a moment the Panzer crew believes the problem has vanished. That illusion collapses when 3 more targets replace the lost icon, closer than before. Adrenaline gives way to calculation, and the order switches to guns. Twin 30mm cannons lock on and spit a short burst, vaporizing a drone in a brief fireball. It is a legitimate kill and also a fatal distraction, because the turret can face only one direction at a time. For every drone destroyed, others exploit the opening and pour through. What unfolds is not a duel, but arithmetic. The Panzer systems win individual exchanges, but the swarm is designed around brutal simplicity. Saturation beats precision when angles multiply faster than barrels can turn. Miles away, inside a Ukrainian command bunker, the controller watches the telemetry and recognizes the break. He issues a single system-wide instruction to the drones that have slipped through, ordering terminal phase autonomous engagement. Human guidance drops away not because it failed, but because it is no longer needed. Optical sensors lock on to steel and shadow, and the primary target fills their field of view. The Russian command bunker is described as cold and dark, a slab of reinforced intent with critical ventilation shafts that cannot hide. BMP-3 crews nearby cannot traverse their cannons fast enough, their systems designed for slower problems, while infantry rifle fire dissolves into fog and noise. The first group of 4 drones ignores armor and aims exclusively for the ventilation shafts, striking in a synchronized volley. Their shaped charges trigger what the narration names explicitly as the Monroe effect, focusing explosive energy into a jet of molten copper traveling at roughly 7,000 meters per second, slicing through 12-inch steel like a cutting tool rather than a bomb. Before the shock can dissipate, the remaining 8 drones execute the main attack, slamming into the bunker's concrete foundation within a tightly timed 3-second window. The overlapping detonations generate catastrophic overpressure, The kind structures are not designed to endure from within. A bunker engineered to survive a single massive impact from above begins to fail when assaulted simultaneously from multiple internal vectors. A reinforced blast door between the bunker and its ammunition depot is blown off its hinges, and heat and pressure flash through the opening with unforgiving efficiency. Inside that depot, 4.4 million pounds of artillery shells ignite almost instantly. The ground heaves as stored energy converts into violence, and seismographs several miles away register a 2.1 magnitude earthquake. The headquarters for 4 Russian brigades is erased, not as a cinematic fireball, but as a sustained collapse that leaves a flooded crater where coordination once lived. Twisted BMP-3 hulks sit half-submerged, and ammunition sinks into a newly formed lake, unreachable and useless. What remains is absence, measured not just in debris, but in measurements across command channels. In the hours that follow, official language struggles to keep up with physics. A regional governor attempts to describe the event as damage to a hydraulic structure, a phrase that collapses under its own weight when compared to the scale of loss. With command erased and rail lines severed by floodwater, roughly 5,000 troops of the 4th Guards Tank Division find themselves stranded. An army on an island without fuel, food, or ammunition. Tanks remain armored but inert, steel coffins or empty shells, while the front line quiets not because of ceasefire but because movement has been drowned. The silence on the front is not empty. It is filled with images. Ukrainian drones, untouched by jamming now that the fight has moved from control to consequence, upload clear footage of the aftermath. Soldiers are seen wading and swimming from command posts that were never designed to be aquatic, rifles held overhead, radios dead weight. The visuals spread through Telegram channels with speed that outpaces official statements, and the message is unambiguous. Senior officers, hardened bunkers, and layered defenses did not prevent humiliation. Inside Russian command structures, the problem is no longer the destroyed headquarters, but the uncertainty that radiates outward from it. Units downstream of the blast cannot confirm orders because there is no one left to issue them, and units upstream cannot move because rails are submerged and roads are compromised. The flood has turned geography into a weapon that persists without guidance, forcing commanders to react to physics instead of tactics. What was meant to be a static fortress has become a liability that reshapes movement and attention across an entire sector. As daylight approaches, engineers assess the dam damage and arrive at a grim conclusion. The leak is stable enough to avoid total collapse, but active enough to keep water levels rising. That balance is the trap. It prevents a dramatic emergency response, while ensuring that disruption continues hour after hour. Repair crews are assembled with urgency because every additional inch of water widens the island effect. The assumption inside Russian planning circles is that the strike was singular, a bold raid that achieved surprise but cannot be repeated under heightened alert. That assumption lasts less than 24 hours. On the night of October the 26th, after repair teams are dispatched and protective details established around the dam, Ukraine fires 3 more HIMARS rockets from a completely new location. The targeting logic is inverted this time. The dam itself is not the aim point. The crews are. The strikes are designed to interrupt repairs rather than escalate damage, ensuring the leak continues and the flood maintains pressure without risking uncontrolled collapse. It is restraint used as leverage, and it forces a decision that cannot be postponed. Russian High Command now faces an impossible choice framed by the same water: protect the armies on the front that are already isolated, or protect the critical infrastructure in the rear that keeps the state functioning. Air defense assets are finite, and every panzer system can only sit in one place. The decision is made to guard dams and bridges, pulling point defense systems from the Vovchansk front and other exposed sectors. With panzer coverage thinned along the front, Ukrainian air operations encounter gaps that did not exist days earlier. It is not that the Air Force suddenly becomes omnipresent, but that the calculus shifts. Missions that were previously too risky are now plausible, and Russian units feel the absence immediately as drones and aircraft probe with more confidence. The trap extends beyond the river, converting a localized flood into a strategic rebalancing of defenses across multiple axes. Behind the scenes, analysts begin to tally what the strike actually cost and what it achieved. Ukraine expends rockets valued at roughly $3 million, a sum that sounds substantial until it is placed next to the effects. Direct damage is estimated at over $100 million when the destroyed headquarters, immobilized vehicles, ruined ammunition, and infrastructure losses are combined. 4 brigades lose effective command, and an entire division is frozen for days without firing another shot. The return is not just financial, but operational, measured in time, seized rather than ground taken. Repair efforts continue under threat, not because additional strikes are constant, but because the possibility of them never leaves. Crews work faster than protocol allows, improvising solutions that hold for hours rather than years, aware that any concentration of vehicles or equipment could attract attention. This urgency degrades quality, and temporary fixes replace durable ones. Each patch becomes another vulnerability, another place where pressure can be reapplied if needed. The dam no longer functions as a stable asset, it becomes a lever that can be pulled again. On the Ukrainian side, the operation reinforces a doctrine built around sequencing rather than mass. The narrative avoids portraying the strike as inevitable or effortless, emphasizing instead the narrow margins and irreversible risks. The planners accept that a single error could have produced disaster, yet they proceed because the potential gain justifies the gamble. That willingness to operate at the edge of control while designing layers of adaptation into the plan becomes the defining characteristic of the action. Information continues to do its work long after explosives have finished. The cost exchange becomes a reference point in internal assessments, not as a slogan, but as a practical benchmark. $3 million in rockets catalyzed losses an order of magnitude higher, but more importantly, they force decisions that weaken the opponent's posture without further expenditure. The strike demonstrates how limited resources, applied at the right junction of systems, can compel an adversary to spend far more just to regain equilibrium. For Russian forces, the lesson is uncomfortable because it challenges assumptions about safety and priority. Protecting infrastructure draws defenses away from troops, yet leaving infrastructure exposed risks systemic failure. There is no configuration that satisfies both requirements fully, and that tension becomes permanent. Every future deployment near water or transport hubs must now account for the possibility that those features can be turned against them. The HIMARS launcher fades from the story as quietly as it entered, not celebrated but understood. Its survival underscores a shift away from platforms as symbols and toward effects as outcomes. What matters is not what fired the rockets, but how those rockets interacted with terrain, weather, human reaction, and time. In that sense, the launcher is interchangeable. The concept is not. As weeks pass, the Belgrade River returns to a slower rhythm, but the operational damage does not recede with the water. Rail lines require extensive repair, command structures must be rebuilt, and trust in fixed defenses erodes. The area remains quieter than before, not because fighting has ceased, but because momentum has shifted. Silence here is not peace. It is the sound of systems recalibrating under strain. The narrative closes on an implicit warning rather than a declaration. In modern conflict, rivers are not obstacles or boundaries. They are variables that can be rewritten. When combined with precision strikes and autonomous systems, even modest changes in water level can reshape an entire battle space. The Belgrade operation illustrates that the most decisive moves may not announce themselves with fire, but with pressure applied patiently and withdrawn only when the structure above it gives way. This is where the sequence ends. Not with resolution, but with a changed map and altered expectations. The trap succeeds because it does not demand continuous action. It relies on consequences that persist after the last launch. Water keeps working, logistics stay broken, and defenses remain stretched. The story concludes with a simple reality. Once the river was weaponized, the outcome by Como rolled on its own timetable, indifferent to intent or spin.